Good af- Good afternoon, everyone, and welcome. I'm Sophie Leone, Development and Program Manager at the Northeast Recycling Council, and I'm excited to welcome you to today's webinar, Hazardous Materials in the Waste Stream, Impacts and Mitigation Strategies. This webinar will examine the growing risks posed by hazardous materials such as lithium-ion batteries and pressurized tanks throughout the waste and recycling industry. From fires and explosions to operational disruptions, these hazards are impacting MRFs, C&D facilities, e-scrap processors, scrap yards, and transfer stations. Panelists will discuss evolving state policies and legislation shaping how these challenges are being addressed today and what lies ahead for future operations. Before we begin, just a few quick notes. This webinar is being recorded, and the recording and a copy of the speaker presentations will be sent to you afterwards. During the webinar, please enter any questions for our speakers into the Q&A box on your window below. Briefly about NERC, we are an 11-state nonprofit organization that works to minimize waste, conserve natural resources, and advance a sustainable economy. We organize educational webinars, offer courses, develop public resources, as well as facilitate cross-sector discussions through our communities and annual Rethink Resource Use Conference. And here's the agenda for today. Next, I will pass it over to our moderator, Leah Kiam. Leah Kiam runs strategy and operations for Vizia, the recycling industry's only multimodal AI platform. Her work focuses on helping facilities improve safety and efficiency by detecting hazards like lithium-ion batteries through burden depth. Before joining Vizia, she was an investor at Blackstone. Leah holds a BA from Harvard University in economics and earth science. Leah will introduce the speakers and moderate the Q&A at the end.
Thank you so much, Sophie, and thank you everyone for joining. I know this is going to be a really informative conversation and one that is definitely a hot topic, pun intended, in the industry. And I feel very fortunate to have an expert panelist with us covering many different material streams. So I think it'll be a great presentation and great conversation post. So excited to hear all of your questions as well. Just to give a bit more background on the work that we do at Vizia and why I'm moderating this panel today. We are a material intelligence platform for recyclers, and our goal is to be the platform to find hazards in the waste stream. Feedstock volatility is hurting operations across the industry from C&D to e-scrap to battery recycling, which will be the topic that a bunch of our panelists will cover today. But we as a platform are across 30 different facilities in the waste stream, and we have customers across the different waste streams. So we'll be discussing all different hazards from lithium-ion batteries to propane tanks to other things in the waste stream. Our first panelist is Shane Thompson. He is the EVP of Strategy at Serba Solutions, and I will turn it over to him now to talk about batteries in the waste stream.
Hi, Leah. Thanks for the invitation and opportunity to participate. About 20 years ago, I gave a talk to Lynn Rubenstein at NERC on battery recycling. So it's good to see that it's been interesting to watch over that 20-year period where battery recycling has shifted from being an environmental conversation to now, including being an environmental conversation, it's also a global economic supply chain conversation as batteries have kind of inculcated all aspects of our life. So what I need to do from a technical standpoint is I'm going to go camera off for a second, and then I'm going to pull up my slide. Sorry, just bear with me 1 second. It's a good thing we practiced this right before. Oh, there it is. I lost the share button. Sorry about that. Okay, we will be. Okay, let me get back to the beginning because we didn't reset from the practice. So I've got about four kind of topics to kind of cover, but thinking through the lens of this topic is how are, you know, what are these materials in the waste stream, right? So our our take on this is I wanted to show you the reason that the batteries are making their way into the waste stream are because the batteries are in all aspects of our life, right? So whether they're small or they're large, there's different nuances, but the batteries end up kind of finding their way into the solid waste stream. So I want to kind of cover a couple things. I want to talk a little bit about who Cerba Solutions is, and then kind of talk about what we're doing specifically from a battery recycling perspective, and then talk a little bit more about what's going on more broadly, how, you know, kind of sustainability, environmentalism, these things have pushed collections upwards, but that's going to be increased also by upcoming extended producer responsibility laws, which will affect what gets collected and how it gets collected. And then kind of want to close with kind of why we're doing what we're doing at Cerba, which is to try and take the old batteries out of the waste stream, get them recycled, but not only recycled into an intermediate material, but back into the supply chain for new batteries. So starting kind of with Cerba, so to kind of give perspective, and given that this group has longevity and folks might know the names a little bit differently. So about 4 or 5 years ago, I started something called Heritage Battery Recycling, and it was done in conjunction with the Heritage Group and Heritage Environmental Services. And again, part of that is the relationship between battery recycling and environmental service, with the mandate to kind of figure out how do we grow in the space. And having worked for the kind of two of the larger battery recyclers in North America, Retrieve Technologies and Battery Solutions, we kind of embarked down a path where we acquired both of those entities. And then about 2 years ago, all of that was rebranded as Cerba Solutions. So I still mention that sometimes. Our marketing people don't always like that, but I try and remind them that, you know, for some folks, they'll remember Retrieve or they'll remember having dealt with Battery Solutions. So I think it's important to understand that, you know, while we have a relatively new name that's emblematic of our kind of position in the market today and what we want to do in the future, we're actually an old battery recycling company. So we've been doing this for quite some time. Some of the key kind of points on the map here are Lancaster and Trail. Those two facilities are lithium-ion recycling facilities. Wixom, Baltimore, Mesa, those facilities act as aggregators for material. They will kind of consolidate, collect, and then inevitably sort the batteries into the different categories. Again, we're focused on. Now, I apologize for the. So they will consolidate, collect, get the batteries going into kind of the right categories, and then they're processed accordingly. So the ones that we're actively processing are lithium ion, lithium primary, and alkaline batteries. So all of those materials are able to be recovered. So that's kind of the Cerba Solutions footprint. So for this being an educational event, I do want to take some time and kind of get into the nitty gritty about the various types of batteries, because I think, I don't know, maybe it's me, but sometimes I think the collection of batteries seems like it should be an easier endeavor than it actually is. So it's actually more challenging than you think. And I think one thing that I've learned over the 25 years is that, you know, the term itself, battery recycling, really isn't homogenous, right? So for this group, if you're thinking about battery recycling, I think it's helpful to kind of think about it in three distinct categories. You know, one category is lead acid. Historical lead acid battery recycling has been around for 100 years. It's very defined. You know, while there's cross-cutting EPA and DOT themes, it kind of operates very, very specifically. So the second bucket is kind of all of these large format lithium ion batteries that are literally and figuratively kind of coming down the pike with whether it's an EV or they're being deployed in ESS, but they're not quite here yet. They're starting to get here and we're seeing them, but those will become bigger and bigger. And then the last category is kind of what's illustrated here on the slide. You can see lead acid and lithium ion are in this category as well, but in the small format, right? And that changes how they're collected. It changes the complexity. So this is really where I think the members or the folks that are listening in on this call, these are the things that we deal with on a day-to-day basis. So kind of getting the batteries identified by their chemistry is really important because how you go about processing them, it varies, and what you're targeting varies. So for us, we're doing this kind of across the broad spectrum. We have everything from a small package that you can buy, as a small B2B and recycle, all the way up to full truckload quantities. So we're really kind of oriented to collect with an all of the above strategy because we found that to be the most effective way to get the batteries in. So keeping in the educational part and drilling down a little bit, right? Like, so these are some of the different types of formats, right? Like portable batteries. That's another word for small batteries, right? So you've got your double A's and triple A's. You've got some power packs, drone batteries. So these are all emerging, and we actually on the last time that we got together to preview this, we were talking internally about like just that I'm an Apple guy, so I have the earbuds in, and that's 3 batteries, one in each earpiece and one in the charging pack. So it's pretty extraordinary that as individuals, we're walking around maybe with 4, 5, 6 batteries on our person at all time. I think that gets hidden in the product. So I think people don't necessarily identify sometimes, and sometimes maybe that hurts how these things end up in the wrong spot in the trash. Something gets thrown away that has a battery in it, which is very bad for the MRFs that have been experiencing a lot of problems with fires. So the batteries don't stay small though. So and again, we can see these. I think the highlight to call out here is like e-mobility. Power banks are becoming a little bit of an issue in terms of air travel. So like the FAA is looking more closely at what goes on. But I think e-mobility is a really interesting one for this group because you're seeing the scooters and the e-bikes. I live in Washington, D.C., and they're kind of everywhere. All of those have a battery. And so whether it's the bike or the battery at end of life, if you're doing a household hazardous waste collection event, these I think are going to become more and more prevalent. And then we end up with the very large batteries. So these may not come across like a household hazardous waste collection entity, but they're out there. And these are the growth batteries, right? These are the batteries both in terms of growth, in terms of numbers, but also in terms of size. So this is an electric vehicle battery. These batteries are typically lithium ion. And for us, there's 2 types of lithium ion out there. And so just generally speaking, a battery is kind of 3 things. It's the anode, the cathode, and kind of everything else. The cathode chemistry, traditionally lithium ion batteries used cobalt. So cobalt is a recoverable metal. Over time, they started to augment that with other recoverable metals, nickel, manganese, there's the lithium in there. But about 10 years ago, they came up with a new type of cathode that was a little bit cheaper and a little bit safer, and it's iron phosphate. The reason for bringing that up is when you're thinking about recoverable value on the back end, that drives whether or not there's a tipping fee or maybe a credit on the front end. So when you're thinking about lithium ion, you really need to understand what kind of lithium ion battery is it? Is it a battery that has mixed metal oxides that can create a credit? Or is it an iron phosphate that doesn't have enough recovery value and requires a tipping fee? Again, lead acid's been out there. Another type that you may see from time to time, it's the earlier version of the hybrid electric vehicles use a nickel metal hydride battery. So again, generally speaking, that's a good battery from a value collection standpoint, that there's typically a credit on the back end of that. One battery or one phenomena that is a little bit tricky for us, and that's embedded batteries. So historically, the batteries the way the 1996 Battery Management Act was written, it really incentivized the ability to separate the battery from the device. So you could conditionally exempt the hazardous waste battery as a universal waste battery if the two conditions of it's intact and it's going for recycling. And kind of that third piece that got lost a little bit was the removability of the device. So for our perspective, where we can shred all of these things, we don't necessarily like to do that. We want to keep the ratio of what we process relative to the battery. So, if the battery is only 5% of the Bluetooth speaker's overall weight, that's not an attractive opportunity for us. It's manageable, but we would like to have that battery removed. So maybe that's something that if there are e-waste folks or ITAD folks on the call, maybe that's an area to collaborate. So again, I hope I'm not overstating this point, but it's just the batteries are everywhere. I worked for an organization and we did a pretty significant survey, kind of polling consumers on, how they felt about batteries and were batteries an issue. And it was really interesting because the number of respondents that responded very favorably, that, well, not favorably, but like a higher level of awareness than we thought on the fact that the batteries were problematic, either from a safety standpoint or an environmental standpoint, skewed, quite a bit higher than we thought it would. So it seemed like a very positive development. But later in the survey, none of the respondents had batteries. So the disassociation between all of these devices that have the batteries and then the products that they have, it was a pretty shocking kind of, I call it the fog of productization, right? That the inability to kind of connect those 2 points. And again, for this audience, I'm bringing that up because, as you're a household hazardous waste collection entity, as you're a state, how are you thinking about this, right? Especially if the battery is embedded. Can we get better education to collect the products as a way of collecting the batteries? Can we, do interim processing where we get kind of recoverable plastics or materials going one way and the battery coming our way? So I think there's a lot more in terms of education, and obviously at Serbo we try and support that through our website and education, and the commercial team, which I lead. We're always willing to kind of collaborate and work with you to help kind of penetrate through this fog and get that. Hey, these are e-bikes, but there's a battery involved, right? It's a laptop, but there's a battery involved. So again, kind of. This will kind of inform a couple of slides down, but I can touch on it right here. This is just reiterating kind of some of the points I've been making, that 98% of Americans, this over here, 37, but only 37%, knew that, well, I guess 63% do know, but the numbers here are just saying that I think we've got a lot of work to do. But what we're doing this for is for these, you hear the term critical materials, and what they're talking about is that, if battery powered products are at the top of our staircase, right? And we all want those battery powered products. What we do at Serba by making a black mass is kind of putting in the first step in a staircase that involves multiple steps. So if we want that to be a domestic supply, then we've kind of got to have all of those steps in place. So one thing that's helping put some tailwinds into that, there are more and more conversations about the batteries. You're seeing extended producer responsibility laws being passed. What these laws are saying are, if you're a manufacturer of the battery, or even sometimes in the product that you use, you have to take a more active role in the collection and recovery of those. So again, picking the batteries up, the logistics, the collection, it's really a challenge. We're working to mitigate that. You can see that's actually one of our trucks there in the background. So, one part of the battery conversation is getting it in for recycling. The second part of the battery conversation is how do we do that safely and compliantly, specifically from a DOT perspective. So again, we support all of those endeavors with DDR packaging. We can provide some guidance in terms of how to do this compliantly. Again, for us, we kind of take this all of the above approach, everything from a small container to these larger formats. Uh, this is kind of cool. It's a battery recycling kiosk. So if you were a company and you wanted to promote recycling internally in your company, we could talk to you about kind of using one of these to incentivize your employees to recycle. And then what we do with it at the end, we're trying to take the batteries, and again, we make this intermediate material called black mass, which has the lithium and the nickel and the manganese. The next step will be to employ hydrometallurgy to get in there and make a mixed sulfate, and then eventually that will get turned into a sulfate that can become PCAM, CAM, cell pack, and we've now got our completed staircase. So Leah, I don't know, were we going to wait till the end and then do?
Yes, I think we'll wait till the end, but please continue to put in questions now for Shane and for his presentation, and then we'll have them go at the end.
Okay, awesome. And then I will, um, I need to get out of, see if I can get into here and then stop share. And I think it's back to you.
Perfect. Well, thank you so much for presenting. And again, we'll talk more about battery recycling at the end when we do our larger Q&A. Our next panelist is Will Hancock. He is the Business Development Manager at OEM Florida, but his career spans over 15 years across recycling, including building out MRFs, and he'll be speaking mostly about the C&D world.
Thank you, Leah. Appreciate it. Let me get into presentation mode here real quick. Okay. Good afternoon, everyone. As Leah's mentioned, I work in C&D, but I also have background in a multitude of recycling. I've built anaerobic digestion plants. I've built compost facilities. I've built battery recycling programs. I've built single stream recycling facilities and things of that nature. So I'm just going to talk about C&D today because that's kind of where my wheelhouse is. I currently sit as the end markets chair for the CDRA. So I oversee all of the end markets for clients in the country, and I help develop end markets and link clients up with end market users. But I'm going to kind of talk about the commodities in the waste stream and then some of the contamination that we see. So obviously, a lot of our waste that goes into landfills every day is construction and demolition waste. But some of the diverted materials that we can get out of this material are clean woods, obviously, non-ferrous, or ferrous and non-ferrous. You've got cardboard, rigid plastics down here in the lower left. The fines from C&D can be utilized as alternate daily cover. And then we work heavily with solidification companies to utilize that material to go into solidification. I work closely with the Recycling Coalition and other companies that do third-party verification on C&D facilities. And one of the things that has been driving lower diversion rates in the last couple of years are these 1-800 junk guys. So we're seeing more and more franchise junk companies coming into the market and offering waste removal, systems and dumpsters and things of that nature. And with that, we're seeing a large amount of contamination now coming into C&D facilities, such as children's toys and mattresses and tires. And we're just seeing more and more stuff that should not be in the C&D waste stream, and it's due to these kind of like house cleanouts and franchise companies. One of the things that I have a large amount of experience is I built a facility in Commerce, Georgia, and it was a $5 million C&D MRF that was fully automated, and it utilized a Comtech ballistic separator on the front end, and it utilized the Zen Robotics sorting the waste on the back end. And it is very close to SKB in Commerce, Georgia. And SKB brought us a load of 150 lithium ion cells that burned the facility to the ground in less than 5 minutes. We went through a very long and arduous lawsuit and ended up settling with SKB after a year and a half of the lawsuit. But as you can see here in this picture, This facility was right next door to a fire hall, a firehouse, and the firemen were running out of the building with hoses, and it still burned to the ground in 5 minutes. Now, Scott has completely rebuilt the MRF, but this can kind of show you the damage that lithium ion cells can cause. And obviously, there are large amounts of wood and plastics and, flammable items in C&D, so it goes up very, very quickly. And the only way to put out a lithium ion battery is to suffocate it. And we were not able to do that. So there are technologies that we're utilizing now to see more of the commodities in it and hopefully drive up our recovery rates. We're starting to see more optical sorters in the C&D facilities, and obviously robotics has a place. I was the North American rep for Zen Robotics for a long time and implemented them across multiple systems. But optical sorter seems to be the wave now of being able to automate and help alleviate some of those contamination issues. Um, Obviously, education is something that we need to focus on for C&D. We have outreach programs. We do school tours at some of the MRFs that I build. And then obviously through CDRA, we have a legislation board. So we work with legislation around the country to help push for C&D recovery. And I work heavily on end market development. We have a lot of end market development that's on the coast, but in the middle of the country, we tend to be more of an island. And as more and more biomass facilities and paper mills start to shut down, C&D recyclers struggle every day with finding outlets for this material, and it really burdens their recovery rates. And things such as tires and mattresses and propane tanks, they can really, throw a wrench in the works, if you will, for facilities. So we hope to work, heavily on education, and we're working on life cycle analysis on products because while making a green building product is great, we need to take into consideration in 20 to 25 years, we may see it in the C&D waste stream, and that will, we have to figure out what we're going to do with it. And I attend the Green Build conference, and I go around to the different booths and I talk to everyone and I ask them what their end of life is, and they kind of look at me with glossy eyes, and they don't really, they don't really consider it. They just think they're building something cool out of plastics and wood products, but they don't think of like what happens at the end. So other things that I work heavily on are government grants for technology that C&D recyclers can use to help identify commodities and help alleviate systems. And Lee obviously works for Visio, which they've made some great leaps and bounds in identifying hazardous materials as they come in. Because if we can detect it and identify it as it comes across the scale, we can save not only the fires from happening, but also the contamination getting into the facilities. Mine is obviously very short and sweet, but appreciate you listening. If you have any questions, I'm going to stick around to the end. So thank you, Leah.
Thank you very much, Will. And again, for everyone in the audience, please continue to submit questions regardless of who they are for in particular, but we'll open it up to everyone at the end. And lastly, our panelist is Jeff Gloyd, who is the founder of Gloyd Recycling Solutions and has been in the industry for over 20 years, including running a large e-waste company. Most recently, he's launched BIDS 23, which is a first of its kind battery shredder. So I'm sure he'll speak of that as well, but we're very excited to have him here to talk about the e-waste sector.
Wonderful. Thank you, Leah. And thank you, everyone, for joining. I see almost over 160 attendees, probably one of the most attended webinars that I participated in. So very exciting. The title of this, and thank you, Eric, for hosting this, is obviously hazardous materials in the waste stream. However, as you heard from Shane and Will, that the focus seems to be very heavily skewed right now towards batteries. And I won't disappoint, I'll be talking about batteries as well. As Leah mentioned, then in waste and recycling, a number
Jeff,
of...
just before you start, do you want to switch to presenter mode because we can see your next slide?
We did this during trials too, didn't we?
I believe if you go to display settings, there's a way to just do a swap, like up at the top where it says
Yeah.
in between show taskbar. and end slideshow.
Oh, sorry about this, everyone. Challenge this morning.
Well, worst case, we'll be well prepared for your next slide when it comes.
Yeah, absolutely. Yeah, it wouldn't let me change that. Let me try again. Here we go.
There you go, swap. Perfect. We see it perfectly.
Wonderful. All right, thank you for that, Leah, and thanks for the help. So where was I? I've been in waste and recycling, operated landfills and hazardous waste operations and medical operations, and since 2013, heavily in the electronics recycling industry in North America, including running some of the largest end-of-life and ITED operations. In fact, I recognize some names on the attendee list, so it's very nice to see some familiar faces. I will be talking heavily about batteries being a problem and what some solutions are as well. However, it's not the only problem that electronics operations are seeing. You've already seen this slide, but we'll just talk about kind of the breadth of the situation when it comes specifically to electronics. And some of this data is pretty old. I grabbed it off of an earlier presentation just for sake of time. But I don't think that the numbers would surprise anyone. There's a lot of electronics that are manufactured, purchased, and then in turn discarded globally annually. I mean, 54.4 million metric tons is over 1 billion pounds, if I'm doing my math right. And most of that is not actually being recycled. They're either going to landfills or contaminating things like MRFs and C&D sites, or likely staying in people's homes and businesses as well. I think we'd all raise our hands if I asked us to, and said we've got an old BlackBerry or something stored in our drawer or a cabinet, along with literally dozens, if not more, other devices and pieces of electronics. As Shane was mentioning, there's a lot of value from a critical mineral standpoint within these items. However, there can be plastics, which are difficult. I saw one question asked that. So happy to give you my 2 cents after my presentation. Plastics are a difficult situation globally right now. Precious metals are obviously performing quite well. However, in newer electronics, companies have found a way to manufacture and work their products with less and less gold, silver, platinum, etc. So all kinds of issues as far as the amount of material in the market. Obviously, China, US, India are the largest producers of e-waste, and globally, this 2023 data, the 17% e-waste is recycled. That's highly skewed by countries that actually have had longer standing legislation and access to collection. So somewhere in Europe, it'd be much higher than 17. In the US, numbers actually somewhere around double barrel digits, like 10% of all e-waste is actually recycled. Happy to discuss how EPR legislation affects that, because it certainly does. Half the states have legislation. Recycling rates are much higher in those states. The other parts of the country, not so much. There's nothing driving the collection locations or funding those sites as well. You can see the market from a recycling standpoint is quite large, 49,000 million, so about $50 billion. So if you've been to an e-waste facility, hit the little hand raise. You don't need to do that, but it'd be nice if we only received electronics, right? And they were neatly sorted by commodity value or by how we'd like to process it. But in reality, that's not how it happens. We're getting this from businesses that throw things into gaylords around pallets. We're getting from HHW sites or municipal collection sites, or from MRFs where the staff are pulling out mixed e-waste and just kind of combining it into super sacks or gaylord, just sometimes stacking on pallets. It also, anytime you have a gaylord sitting on a pallet, ends up being a nice place for staff to put anything else they don't know what to do with. I think that's a struggle at MRFs. I'm sure that's a struggle at Shane's facilities as well. And what goes in there? Obviously, batteries. Sometimes we know the batteries are coming if it's embedded or if it's part of a contract, but sharps are still a problem. Mercury-containing devices. Mercury's starting, or for the last little bit, has been leaving the market as far as new products, but it's not gone in the waste stream, as everyone on this call recognizes. Propane tanks, rare to see the big tanks, but the 2 pound tanks, very easy for someone to say, I don't know what to do with this, and throw it in with printers or kids' toys or other mixed electronics at a collection site. Paint, still a problem. If it's latex paint, it's just a mess. If it's oil-based paint, sites really can struggle with what to do with that. And then mixed chemicals, kind of representative of bottles, anything and everything, including outside of chemicals, floor sweepings. I can't tell you how many times my team members have been upset because half a galer is filled with dust and debris that are clearly just swept off the floor and then put into an electronics bin and then sent to a recycler. What's the current process? I'm going to keep this kind of high level, assuming we've got different levels of understanding of the recycling industry, particularly e-waste on the call. Right now, there's, to the best of my knowledge, 36 end-of-life shredders in North America. That seems like a lot. It's not. There's still a large quantity of e-waste that is gathered and exported, some of it illegally, for another conversation potentially. But those 36 shredders have to manage quite a large amount of volume that's collected within the U.S. and primarily Canada. Of course, those shredding operations don't just do shredding. There's some manual disassembly, and usually it depends on the value of the material. You want to get a clean circuit board. As Shane mentioned, I'll mention here in the coming slides. Batteries embedded in devices, a significant problem. The shredder you see in this picture is a large dry shredding process. This is essentially what will be mimicked at all 36 of these end-of-life shredders in North America. If you put a reactive battery in there, you will have fire. You put too many large reactive batteries, and you will burn that shredder and potentially the facility to the ground. So a lot of manual sorting and a lot of manual separation related to the hazards, particularly around batteries. When it comes to electronics waste, we don't just have end-of-life operators. We have hundreds of ITAD refurbished and resellers. These are operations that don't really do anything as far as end-of-life recycling, except for gather, sort, and then ship to one of these large end-of-life processors. Their focus is on items that are reusable, that can be refurbished and put back into the market through eBay or through wholesale markets. So what are some solutions? So it's nice to not just talk about the problem, right? So we hear that a lot on these types of presentations. What are some solutions? So identifying and removing the items. Leah mentioned her company, Vissia. I actually am proud to say that I was an early adopter of Vissia and helped them build one of their product lines. They have many product lines, but an X-ray unit that we used at e-scrap operations, 4 large end-of-life e-scrap operations that I was running across the country. And that X-ray unit can identify not just batteries and battery chemistries, but other non-conforming items, dense metals, propane tanks, other hazards that we would not want to put into our shredders. And it operates much more efficiently and quickly than having some individual staff person go through every one of those items. So very effective, and I think we'll see more and more of that kind of hardware tied to AI technology, whether it be Vissia or other companies moving forward. The only other solution is manual, putting people on a table. I've done that. 10 people at a table, you dump the material on the table, you maybe put a walking conveyor on it, and you train folks to identify what might have a battery or what a propane tank looks like, or obviously sharps and how to properly manage it and how to properly dispose of it. Unfortunately, you have to also have, that's proactive. We have to have reactive systems. So having a strong fire suppression system, as Will mentioned, when you get thermal runaways, it's very difficult to dispense of that reaction. Water can be used. There's a myth that you can't use water in lithium batteries. In fact, it's the most efficient. You just need a lot of water. So we're not talking about sprinkler systems. We're talking about deluge systems where there can be large volumes of water that can dump onto a battery part of it in a shredder or on a tipping floor. There's some technology you've heard of, like Fire Roller, that kind of does something similar from an automated standpoint for warehouses as well. New technology, I'm going to show you something we've developed here at Globe Recycling called battery and device shredding. This answers a lot of the questions that Shane had mentioned, as far as not being interested in the kind of contamination of running a high plastic items. I saw some questions in the question and answer session, as well as like what are solutions, show you what can be a potential solution for some folks. And then I always want to focus on the value of material. So who's paying for this? That came up in one of the questions as well. I responded to, happy to answer more. If this is part of an EPR program, well, who sets that price? Because the cost of disassembling an ear pod with 3 batteries with almost no weight to it is way different than taking a battery out of a laptop, or way different than taking a battery out of a large kid's toy. The metrics are completely upside down for most e-waste operators in managing those products. So who's paying for it? What's the value of it? Sometimes there's a positive value, but is that offset by the cost of attaining that separated battery, or that nickel cobalt value? And then who's paying that price? If an e-waste operator receives sharps containers, is there a contract that allows that to go back upstream to charge that back? Most of the time there is. Sometimes it's difficult. A lot of times just education, which I'm not opposed to. So hey, be careful not to put sharps containers in here. We managed it, but in the future, let's make sure we're not putting our staff at risk and adding costs to the system. All right, let's see if we can make this work. Here's the battery and device shredding system. It has sound. I don't think the sound's going to work on this, but there is a link in the notes. It's about 2 minutes long. So, as I mentioned, that's just one solution. We think it's potentially change the industry dealing with is really the most challenging item that recycling facilities see. I like to talk about the future as well. So, what's the next hazard that the e-scrap operators, or maybe MRFs or C&D, or landfills in general see? Dot number one, we don't need one. This industry is hard enough to operate in, and the idea of something new that can be hazardous to staff or facilities would be nice if we didn't have to deal with that. Some of the items that folks are talking about being the next issue, solar panels. I think some on the call probably are familiar with the challenges with solar panels. Flat panel TVs, although there are some options, there's some questions about how do we deal with the influx and massive volume when it comes to that in the e-scrap world as well. And I do think there needs to be a focus on policy, but it needs to expand beyond the early adopter states, and it shouldn't be a shock to anyone to call. When you look at EPR, it's starts in Maine or California or Minnesota or Oregon and Washington, and maybe move to five or eight more states beyond that, but then it stops. And that pretty much is what I've seen in my 20+ year career in this industry or in the waste and recycling industry. We really need something to be broader than that, so there's access for all residents and all businesses across the country. And that's it. Back to you, Leah.
Thank you very much, Jeff. And thank you for shouting out some of the other hazards like dense metal objects, pressurized tanks, sharps. I know there's a big focus on batteries in the questions, and it's a big focus of the industry. So maybe that's also a good place to start for all of our presenters. I know this question was originally posed to Shane, and Jeff, you hopped in the chat, but with so many batteries embedded in electronics, what solution would be preferred? Put these products as covered products in electronic EPR laws or in battery EPR laws? Shane, maybe
Shane,
do
do
you
you
want
want that?
to start?
Oh, yeah, sorry. Um, yeah, I mean, Jeff's right in terms of the history kind of battery legislation, right? Like, part of this was, historically like, well, let me go back even one step further. Something's hazardous from an EPA perspective, either because it's characteristically hazardous or it's listed hazardous waste, right? And historically, batteries had RCRA metals in them: lead, cadmium, mercury, silver, right? So when the 1996 Battery Management Act was passed, that was a very helpful endeavor. And it kind of started the way Jeff said. It kind of had this quilt effect where you have Minnesota doing one thing and California doing one thing. So then the idea was to get a federal harmonization. Um, then now two things have happened. Nickel metal hydride and lithium ion don't have RCRA metals. Now the EPA has kind of gotten around to saying, well, it's D1, D3. But again, we're now kind of back at this point of where, you know, do we need harmonization, right, about the collection? And so even though that's specifically for lithium ion, some of the EPR legislation is really focused on the primary batteries as well. So the idea, I think, is to look to, maybe systems that have worked that promote legislation where the stakeholder or the manufacturer is more involved in the collection, and that's inevitably going to drive collection. Because again, our example, like through the different chemistries, I do the battery recycling and I get nickel, cobalt, manganese, right? That's worth X. Here was my cost to recycle it. Am I positive or negative out here on the front? Right. And so the idea is with manufacturers, can you get more support? So obviously there's a lot of folks that don't like, the regulatory approach, right? That feels that it puts more owners. It's harder to understand. So there's there's a little bit of a battle, but what is unique, I think, going around this go or at this particular time is, Nebraska passed an EPR law, which, that's not one of those states that you would think of as kind of being out there on the forefront. So it does feel like the EPR has legs.
Jeff,
Yeah,
is
would you
there
like me to
something?
add something? Yeah, Leah, I'll add something. Maybe hammer a couple more of these questions here that I'm trying to read through quickly. And I agree with everything Shane said, and I like to see places like Nebraska and some other states that typically aren't who you think are leaders in the EPR side, particularly around batteries. It's such a problem. It doesn't matter where you are. Every waste and recycling, every hauler is dealing with these problems. So I think we're starting to see state legislators outside of the key, states open their eyes to something needs to be done. And what that is the question mark, right? Like e-waste legislation, 26 laws of 50 states, and Washington, D.C. And there's not one that's the same, right? So how you manage that from a recycler and operator standpoint becomes really, really difficult. The economics are all over the board. Yeah, I'd like to see something on the battery side avoid that, right? Where there's something that's fair and equitable for residents and business to be able to collect or to deliver their batteries, but also fair for haulers and and recyclers as well. If I could see a question here from Martin. These recycling programs for single-use batteries, is it profitable recycling? Well, I'll tell you, it's easy to determine. If your recycler is charging you, then there's not enough value in the battery itself for it to be profitable. And these rates have changed dramatically. Not to throw Shane's pricing sheet out there, but the cost of recycling an alkaline battery, I've been in this industry a long time, used to be 15 cents. Now it's 40 cents. There's some charging as much as 70 cents. Why is that? Well, the recoverable value of their zinc manganese has changed, or the cost of producing that zinc manganese has changed. Profitability needs to change, right? So the pricing in the market kind of determines what that value is. Lithium-ion batteries used to be a payable of $1.40 a pound. Now it's 70 cents a pound. So the cost of getting that value has gone up, which means what they can provide back to you has gone down.
Thank you. And I guess a good segue related to emerging battery trends and their potential for second use. One question was around mid-format and larger batteries, and I guess Shane, maybe start with you. Ones that have considerable energy potential. How does CERBA see this opportunity?
Yeah, from like a current state and a future state. So
Yeah.
kind of in the current state, with the caveat that like if you take a 1974 Buick and a 2022 Buick to a shredding operation, they're worth about the same, right? You take them to a used car lot, well, that one's going to get a lot more value, right? And so batteries are kind of the same way, right? There's kind of always going to be, especially in a smart battery system like a lithium ion where you have a BMS, you have some power electronics, there's always going to be more value as an energy storage device. But it's tricky because batteries are made for specific applications. So manufacturers of the batteries are very, uncomfortable with, hey, that battery was built for this. It was tested for this. So we'd like it to go into this application. I don't think long term there's going to be enough of an argument to overcome that value. So I think eventually, especially, heavily engineered batteries like EV batteries, right? Going into maybe softer applications like frequency regulation or peak shaving, right? Designed and tested. And so I think we're still seeing that play out in states like California, where you have kind of stranded solar. There's kind of a B2B market there where they're trying to find, energy storage applications. So I think it's still early days. Macro picture, I think it makes a ton of sense. For CERBA, we have shredders, so we we like to recover the materials in there, and again try and create more value by creating a domestic supply for those materials for the battery supply chain. But certainly, as somebody who's been doing this for a while, you can see that, yeah, that there's a market there. I think things still have to be figured out before we see it get more mainstream, but there's stuff happening.
And then I guess on the flip side of things, a different participant asked about the smaller batteries, e-cigarettes, vapes, those, and if there's been much discussion on research considering the amount that we're seeing in the waste stream, rather than just focusing on EV and medium sized.
Yeah, sorry, I'll take the first swing, and everybody else can weigh in. Vapes are tough, right? Like just because. So back to that characteristically hazardous versus listed, right? Like nicotine is a P75 waste code, right? So there's very specific permits required to manage that material. Cannabis is a whole other potential set of issue, even though the vape industry would tell you, well, the majority of the vapes use things called flavors, right? They're not really nicotine or cannabis, but we don't have any way to know that, right? And so as a recycler, we're very cautious about engaging because, we've had conversations where we've dealt with an OEM who's like, hey, these are new. They're just QA/QC. We need to get rid of them. They have a battery in them. Can we recycle them? Right. And it's tricky. We're actually partnering with a company that does nicotine recycling. So they're a vape kind of focused where, hey, we can send you the pens, you send us the batteries if they're removable, or otherwise mitigate the nicotine fraction and then send us something that we can safely and compliantly process. But for the household hazardous waste collection people, up to and including one I was with a couple of weeks ago, where the local high school was the largest contributor to the HHW's problems with vapes, confiscated vapes.
And yeah, I would just add on to this from the Vizia perspective, because we work across all different types of material streams. We're seeing vapes end up everywhere and they're causing issues for thermal vents. It's not just the big batteries, it's the little ones. They can be small embedded because of thermal runaway properties that Jeff started to speak about as well. So definitely a big concern for the industry and something that we're keeping our eyes on closely.
Yeah,
Another
let me just maybe if I could add, Leah, because there are solutions, right? And the the issues are easy to stand and grandstand about, right? That's a frustrating thing that all of us, I think, have been part of. You go to a conference, all you hear about the problems with vapes, right? What are the solutions? You can't send them to Haz Waste at $9 a pound. That's not a solution, right? Well, there's a solution because and a solution is dependent on following the regulations as they're written. And what makes nicotine hazardous is the generator. If it's generated from a household, it's solid waste, but it's exempt from hazardous waste regulations. It can absolutely be managed. Okay. Folks that have RCRA permitted sites like Serba, shout out to Shane and their Lancaster location, they have a Part B site. They're able to process hazardous waste. Maybe they don't want to, or that's the part they're discussing, but you can work with RCRA permitted sites that aren't just hazardous waste incinerators. But if it's generated from a household, it never becomes hazardous. You can run it through a bid system. You can do other things with it. You just have to use work practice environmental controls. I'll say the same thing from material generated from OEMs. Okay, this is a big one, and I'll kind of segue a little bit here. Most of the big EV battery recyclers, most of their volume is not coming from EV batteries coming out of cars and trucks. It's coming from manufacturer scrap. That's still today the case, and probably will likely be the case for the next 5 to 10 years. The vape industry is creating a tremendous amount of waste, particularly when states say, hey, you can't have grape flavored vapes anymore. Then all of a sudden there's 200 trailer loads of grape flavored vapes coming out of Kansas spread. And this is happening today. What do you do with those? Well, there's an exemption called reclamation, and EPA recognizes reclamation for the device, not for the nicotine. So as long as that vape is being recycled, and there are options for that, you've seen that, then it would not be considered solid waste. And if it's not solid waste, guess what, everybody? It's not hazardous waste. So we need to work within the rules while also addressing the concerns that might be related to something that could be hazardous.
I want to switch gears a little bit to talk about municipal sites and consumer education. So first question in this category is, what kind of guidance do you give to municipal collection sites for how to discern between different types of batteries and guide residents with what is acceptable and what isn't?
We support, like I said, our website, we try and have like, hey, here's a battery guidebook, right? With just some of these key things. This is a picture of an alkaline battery. These are the types of applications that alkaline batteries are found in. When you get into the specifics of this is a lithium ion battery, hey, there's two types of lithium ion batteries. So you got to try and figure out which one's which because they have very different economic outcomes. So we can do that kind of passively through printed work, web-based support. And we're certainly happy through the commercial team to engage kind of one-on-one. So, if you were a new HHW and you were adding batteries to your collection mix, we're happy to kind of meet with you and kind of walk through some of those guidelines around. But yeah, 90% of the battery stuff will be relatively straightforward, right? Like this is a lead acid, this is alkaline, right? But you do have that 10% that the battery industry loves to make like little widgets and little variations. So, we would try and work to get the 90% taken care of and then kind of have us be a reach out resource for the kind of the anomaly stuff.
Okay, and then part two from someone in the participant section, is it preferable to advise consumers to dispose alkaline batteries in the trash or recycle along with e-waste? Is there value in alkaline materials?
Yeah, that's an interesting one to watch over my 20-year career because like early days, right? It was no, throw them in the trash, it's benign. And then, then it was like, well, some life cycle studies have been done and it's actually really bad because the zinc comes from a mine in Alaska and you have all the carbon implications. So the short answer is yes, there's value. The harder part of that is there's not enough value in the current market to kind of make it all the way back to create some type of financial incentive. Right. So there's still a fee associated with it, but it's a significantly better environmental outcome than primary zinc mining.
And then
There's so little zinc in the zinc manganese black mass that primary smelters, even zinc smelters, are not interested. They'll charge you to process it. Most, if not all, zinc manganese black mass in the U.S. goes to fertilizer and ground application for the manganese content, not the.
And I was just going to ask a follow-up, Shane. I know you mentioned iron phosphate in your presentation, but what other emerging trends in lithium-ion battery formats and chemistries should waste professionals be aware of as it relates to safety and potential cost for disposal?
Yeah, the new trends. I think, I had I was asked to participate in a consulting thing. They were looking at deploying renewable energy, and they were looking at these flow batteries, and it's a new type of battery, and they were like, "Wow, it's really interesting and promising." But at the end of the day, the lithium ion battery has been evolving over the past 25 years to where it's really got kind of its stroke down. So it's being able to be manufactured at really large numbers. So even though there may be an emerging technology that has some technology promise, I don't think there's anything that's, the battery industry has solved all the easy problems. So you'll hear things about solid state, right? And some different types of technology advancements, which I think they will come to fruition. But I think by and large, the lithium ion battery has found its place. It's really just because it's going to be, I can go there, I can order in mass, I can get a warranty, I've got 20 years of past performance to understand it. So I think just all of those things kind of outweigh the the technology upside potential of any given chemistry. But again, that being said, with somebody who takes old batteries and doesn't necessarily make new ones, so with that caveat.
I want to switch gears to talk about another material, which is rigid plastic. So this question is for Will. In upstate New York, I've been told that there's no real outlet for rigid plastics. Most transfer stations don't separate them from the solid waste stream that goes to the landfill. Can you discuss the recycling of rigid plastics a little more?
So Lee, I answered that in the
Oh, you got that
chat,
in the
but
chat.
yeah, no worries. I answered it, but I can touch on it just in case anyone else didn't see the answer. Rigid plastics are obviously tough right now. The commodities are down because oil prices are low, but there are outlets. It's just a matter of whether you're near a rail spur. If you have access to a rail spur, it can make getting rid of those commodities a little bit easier. And it also comes down to the quality and the polymer. So lawn chairs, buckets. The problem with C&D, a lot of those buckets still have spackle in them. They still some of them use them to mix concrete or mortar, things of those natures. So that really can hurt the plastic processor. If you put that in the middle of a bale and they get it, then they'll cut you off. So you have to be very, very specific about the rigid. And I'm happy to link you up with processors. Vinyl siding is very, easy to get rid of. The Revinylize is a program that's here in the United States that helps C&D processors link up with vinyl siding outlets, and Ohio is doing massive amounts of rigid plastic recycling. So just matters where you are and how close you might be to someone who can utilize it, and I'm happy to help.
All right, well,
link
thank
those
you for
up.
expanding on that.
Yep.
I know for us at Vizia, we definitely focus on the hazardous events that come with these items, like thermal events, explosions that are obviously a huge safety problem, leading to equipment damage and also causing downtime. There's a question in the chat around equipment that I wanted to touch through because obviously there's a lot of operational challenges that come with various types of material entering your facility or your yard. So for the panelists, how do you deal with the raw materials eating away at your equipment when you're processing them? What equipment wears the most? Do you bail the parts at the end, or what is the product you sell out at the end?
I fully understand the question, but with e-waste shredders, the major wear parts are going to be belts, which can be impacted by non-conforming waste or hazards, particularly if there's battery fires or something else that could impact the belts. Putting too much ferrous or thick ferrous can wear knives and shredders. That's just kind of a maintenance issue. You'll see that at other operations as well. I guess from a battery embedded device, there's some, when you're using or plastics recycling, I'm sure we can speak to when you're using salination tanks to sort material, the type of media you're using for your tanks is important. If it's a poly tank or if it's a high grade stainless 316 or 316L or something is very important. And that just is, preventing, maintenance or replacement of equipment. In this industry, no matter what you do, you're always going to have wear. It's just a matter of how long you make the stuff last and be effective before you have to make changes.
Thank you. I'm going to turn to Shane with a couple specific questions about the work that CERBA is doing. So firstly, what is CERBA doing to make recycling batteries more accessible for community programs that are not solely focused on battery recycling, but manage other materials?
I think the answer is, the kind of the diversity of how we take the batteries, right? So, if you're not generating a lot of batteries because you've got a more holistic program and you're doing lots of things, then maybe our small package program that you fill up, a couple times a year is sufficient. But I guess I think how we're probably most effective is if somebody did bring in 2 pallets of lead, you could pick up the phone and we can manage those as well, right? You wouldn't have to find a lead smelter. We could kind of get you pricing and kind of work on the transportation. So I think our our ability to, we don't have minimum quantities, more is better. So I think that ability to work with the established and emerging kind of household hazardous waste collection entities is a, a good quality.
And then could you speak a bit to the Big Green Box program? Is it going away? Is there something to replace it? And any work that you do with Call to Recycle?
Yeah, we have a very comparable product to what Call to Recycle uses now. We did get away from the Big Green Box brand. That was a historical retrieve brand. We like that. That was I think kind of innovative for its time. Um, I spent 2 terms with Call to Recycle. So I'm a fan of the work that they're doing. They're funded by the battery industry to go out there and raise awareness about the need to recycle and then kind of facilitate that specifically, at a consumer level. So we're a battery recycler. So they make a good partner for us in terms of being somebody who can take the batteries that they collect and process them. It's a good organization.
Thank you. Will, question for you around material streams in C&D. I know Jeff mentioned in his presentation around future hazardous material and looking a bit on the horizon, not that we want to add more to our menu, but I was hoping you could touch a bit on what you're seeing across C&D and anything to look out for in the future.
So, in preparation for this meeting, I sent a text message and I started a group thread with some C&D processors, and I'll read some of their wonderful answers. It's actually quite hilarious. Terrell Garrett is in Portland, Oregon. He owns Greenway Recycling, and his his first answer was a llama in a woodload. So there you kind of see everything. And then Brock from Premier, his answer was insulation with conduit wire wrapping around like a bird's nest, broken acoustic ceiling tile with good gypsum board. So that's another thing too, is products that look very similar to something like gypsum, which Armstrong has a program where they will accept ceiling tiles, but of course they have to be palleted and they have to kind of be in perfect condition. And a lot of times with C&D, you're getting mixed loads coming in from demolition contractors and new building contractors. So I work heavily with trying to help demolition contractors understand the process, and I bring them to MRFs to kind of show how the process is so that perhaps on the front end they are more cognizant of the material that's going in their dumpsters and trying to keep clean wood loads and trying to keep clean metals and clean aggregates, things of that nature. Because if it can come into the facility and go right to the bunker, that saves not only the equipment from wearing, but other things like that. So I would say the hazard for what we're seeing most right now is a lot of propane tanks and a lot of the smaller like camping propane, like the smaller 1 gallon or like the Coleman ones. And because people don't think and they just throw them in the dumpster, and of course most of the systems that I install and integrate have shredders on the front end. Zanker Recycling in California, they actually have a hood over their shredder just to stop anything from when they do get a propane tank from flying in the air and injuring anyone. I once saw a 2x4 shoot through a 35-foot roof and everyone just scatters. So I would say obviously lithium ion batteries are, we've all talked about it. That's the biggest headache right now because they are, as we've talked ad nauseum here, is they come in many different forms. Just the other day, I was at a site and a DeWalt battery was smoking as it was coming up the line. So, you think of those and contractors just throw their battery in the dumpster and don't think, well, that's not where that goes. Um, Companies like Home Depot and places like that do have battery turn-in programs. So there's that. I would say also is newer building materials that don't have end of life. Things like Trex or Hardy board and some of these newer gypsums where gypsum is, it's enforced with fiberglass. So now a gypsum recycler can't take that because of the fiberglass. It contaminates the whole load, but it's hard for an optical sorter or a human to even see the difference between the board. Now, some of them will be colored differently, but it's very troublesome. So
And then a follow-up from the chat is, do you have best practices for what materials can and cannot go into C&D facilities or what education materials are available?
oh, that's tough. And it's kind of what I talked about with the rise of these franchise dumpster companies. We're not able to control the material coming inbound as if you are to just have your own waste and control. We do things where we print pictures on the side of dumpsters of what can go in there and what can't. But it's very hard. I mean, that's what I said, education, and we have to work harder on educating the populace about what should be put in dumpsters and what shouldn't. And I watch it happen on my own road. There's a dumpster sitting out in front of someone's, remodel or things of that nature, and people are just driving by throwing their garbage in it, or, they throwing a couch in it because they found a free place to dump. So better enforcement on illegal dumping and education, unfortunately, is the best. So
I like this question in the chat. If this was a baseball game, what inning are we in terms of figuring this new system out? This is a little bit more meta.
yeah, I don't even know how to answer that. I don't think the game's started yet. I think we're still trying to figure out who's pitching.
I guess to frame it another way, given that this is a puzzle to figure out amongst producers, policymakers, manufacturers, recyclers, what do you see as kind of the role each should play in improving safe collection and processing of these types of materials? A little bit more open-ended.
I'll take it for just to start with the manufacturers. Companies like Owens Corning, Armstrong, shingle manufacturers, OC, they're getting more heavily involved in the end of life for their materials. So there is good pushback from the industry to start calling out these manufacturers and saying, listen, you have to understand what the end of your life material looks like and what are you doing to contribute to the infrastructure, right? Our biggest problem in the United States is infrastructure for not only recycling but also utilizing those end markets and products. So they are being called upon. I think CertainTeed has now developed a system where they take the asphalt shingle and they pelletize it, and that pellet can go back into asphalt for the roads, or they're working heavily on trying to figure out how to put old shingles back into new shingles. So, but I'll let Jeff and Shane talk about the other side.
Yeah, it's a really good question, interesting point. I like to hear things like what Will's saying, where manufacturers are actively engaged. My experience, maybe I'm a little jaded here, is that it's a lot of lip service. Manufacturers are in business to typically make products and sell products, and anything on the ESG or recycling side ends up being a burden for them. I've seen that with OEMs on the electronic equipment side for a very long time. And anytime there's an ability for them to cut back on recycling to make less of a spend on the cost center, they'll probably take advantage of that. Look, if it was easy and manufacturers were engaged in recycling with all of the hazards we're talking about, all of the value chain issues we're talking about, there would be 50 state solutions, and there's not. So I'm a little more pessimistic when it comes to leaning on manufacturers to do the right thing and be part of the solutions, either on the design side, fail, or on the collection and access side, also fail. I think it needs to be more of a state, local legislation, and like anything else. And I'll get off my soapbox. Follow the money. If companies can make money in recycling, products will be recycled. If they can't make money at it, or it's not getting subsidized enough for them to make money out, if there's too much risk, then there won't be significant investment into recycling systems.
Yeah, I think, again, having watched this unfold over a long period of time, I think largely the unfortunate reality is kind of what Jeff described, right? And the only two things I would say, like I think the manufacturers could help with the education piece and kind of break through that this is a product, but it's also a battery. Here's what you should do with it, right? Like that doesn't necessarily cost, but that could really be important in kind of raising the consumer awareness that, oh, hey, when this thing reaches end of life, because as other drivers, right, the younger you are, the more kind of environmentally sensitive you are statistically, right? So if I know about this thing, then I know to take it back to the store that I bought it, or which again, it creates other issues, right? Because those folks are interested in selling things, not being a collection point. But again, this other part is kind of like a little bit like more, like I'm not sure how the US is going to respond to, making batteries is very specific, right? Like 25 years ago, we sent stuff to Asia because it was cheaper. Now they have the know-how. So if we want to reshore kind of things like, battery manufacturing, well, all of those steps that I mentioned, you have to bring kind of all of those over. So if there was a supply chain concern, would that genuinely change the manufacturer's behaviors? Because now what's motivating them is access to a certain material, right? That maybe due to other geopolitical issues is now more attractive to have a domestic option for that.
I guess a follow-up there, are there any geopolitical events, issues, policy that you're following that's directly impacting where the battery recycling industry is going right now?
Well, I mean, I think the battery recycling industry to a certain extent follows the battery industry, right? And so, I think that there's, I think these two administrations were, trying ostensibly to do the same thing, which is create domestic manufacturing, right? One was using a carrot, this one's using a stick, right? But the idea is kind of the same of, hey, we want you to build stuff here. And so I think as a battery recycler, we need, Jeff pointed out those, the gigafactories, right? They'll be a large source of recyclable material till the end of life, large format batteries come. So I think we trail a little bit behind those guys. So I think looking out, it'd be nice in the next year or so to get a little bit more clarity. And some of these factories that were announced have announced that they're not coming. Right now commodity prices are at an area where a price where they're kind of a disincentive to do anything and put capital out there. So I think a couple of macro things have to happen to kind of get that momentum going. And then with the battery momentum, I think then the recycling kind of follows suit.
Makes sense.
Yeah, I'll add to that, Leah, if I could. The Department of Energy, Department of Defense, particularly Department of Energy recently has in the last 3-4 years has created a very large slush fund of available funds. Those funds, as of the last 9 months, have essentially disappeared. So there's some geopolitical issues that are impacting the recycling market. And was there overfunding of new facilities where there's much more capacity than there was volume currently? The answer is yes. But that's kind of how the government works, right? We're going to overfund 10 processors for the hopes that one can actually do it right, and then they have a long-standing business. There's just less access to that kind of slush fund now, and and probably moving forward, unless you're specifically related to critical minerals. So that's on the battery side, there's still hope because of nickel, cobalt, lithium, and other critical minerals. One of the things I follow often is the Basel Convention, right? So the U.S. is not a signature to that treaty. We're only like 4 or 5 countries, including Liechtenstein and North Korea or something. So it does put strain. And if you follow REMA, old ISRI, there's all kinds of ups and downs about that, and whether we want to sign a treaty like that. I don't have to get into the details, but it does impact the ability for folks in our industry to move material. And the plastic side, Will spoke to this. On the e-scrap side, there's only a handful of folks that can make money recycling e-scrap plastic. There's so many of it, and it's not very valuable. We don't make anything out of ABS plastic in the United States or Canada. We just don't, and if we do, it's a lot cheaper to buy a virgin material made here that 5 miles away from my house in Houston, right? But there are companies in Malaysia that do have strong systems. I've seen them, and they pelletize and send the plastic to China, where they make more kids' toys and more mice and more laptops. But the Basel Treaty does not allow our operators, to send material there. It definitely negatively impacts the value chain. And yes, there needs to be controls. There needs to be safety, and make sure you're working with good, great vendors and folks that are actually doing the right thing. But not being part of a treaty like that can have some pretty negative impacts on recyclers domestically.
And just to touch on that, I thought I would add too. I mean, obviously, what really drives recycling is landfill tip fees, and we're at a point where the middle of the country. I mean, in Colorado where I live, you can dump waste for $18 a ton. So that doesn't really motivate anyone to recycle when you can bury it for so cheap. And management's business model is to bury it and cover it up. So when we start to reach a point like Europe is, where Europe has no, more land for landfills, we'll start to see higher landfill tip fees, which will drive infrastructure and will drive recycling, because those costs will drive people to want to recycle, because it will be so expensive to tip the material into the landfill.
I guess a bit related to policy, I know we've touched now on tip fees, we've touched on EPR. Is there anything related to labeling laws and truth in labeling laws that you see as being helpful for helping to solve this issue across our country?
I don't
Labor
know of
laws?
anything. Yeah.
Labeling
Oh,
laws.
labor.
Sorry.
You would know better than us, Leah. Are you seeing it with Vizia? I mean, you guys would be the drivers behind, kind of helping those labels even be
Yeah, well,
distinguished.
I bring it up too because for us, we see the lack of data across the industry as one of the key issues, both at the facility level to be able to understand what you're actually processing, what's causing issues in terms of, batteries that could be causing damage, but also for your own manual auditing purposes and compliance purposes to be able to have visibility into what you're processing. But then also on the industry level, there's clearly a lack of data to understand what's actually in the waste stream. Problem is getting worse, let's say, across vapes and other types of batteries, and to be able to know what we're seeing on an industry level helps to inform policy. So definitely, yes, it's something that we're following. A couple questions that we haven't gone to in the chat that I want to make sure we hit before we get to time. Is I want to hear about programs for recycling household single-use batteries. Is it profitable to recycle them?
Yeah, just to recap. So it's profitable if somebody's paying, right? So it depends on how you're collecting. I have to charge a tipping fee because the zinc and manganese that's recovered on the back end, there's not enough value created to offset the cost of rendering it into the form that's sellable, right? So there's a tipping fee, and then that fee typically varies based on volume. So if the person is asking, is it profitable, meaning will you get paid to recycle alkaline batteries? The answer is no. But again, Jeff brought up earlier, like another reason why there's price variability in this instance, Jeff, would be like if I'm at 30 cents a pound and you take it out to your customers, now you're at 50 cents a pound, right? So there are scenarios too of if you're dealing directly with me, you're probably going to have like the lowest version of those numbers. If you're dealing with an environmental service company or somebody else, they're probably going to mark that up.
And then, do you recycle damaged or compromised lithium batteries?
Yes, DDR batteries from a processing standpoint are really no different than a regular battery, right? It's the same process. Everything that happens before it goes into the shredder is where it becomes tricky. We have to store it with, a higher degree of scrutiny. We've got, fire systems built into our racks. The packaging that you use, you want to use a more performance packaging, something that's designed to mitigate thermal propagation in transit. So yeah, so we definitely see DDR as its own category, and we manage it differently up to when it goes into the shredder, but then it's just like any other battery.
Thank you. There's a question in here that's talking about manufacturers covering some of the disposal costs and if there's hope. So maybe if someone wants to touch on hope for EPR and kind of where you see that going in terms of helping to solve this issue.
I mean, I think, don't they do it with refrigerators, white goods now? Like the manufacturers actually pay a percentage to make sure that they get disposed of properly. Is that, if I'm not mistaken, I may be speaking out of turn there, but I think more programs like that need to exist where, manufacturers are helping cover the disposal. I don't know of any that are on the table, but maybe Shane or Jeff know better than I do on the lithium. They're obviously much more versed in the lithium side, so.
Yeah, no, I think concept wise, it's kind of the same, right? And another example would be like in Europe, it's very defined, right? There are eco fees associated with whatever
Yeah.
products, and that's kind of the idea. So here, it's kind of happening on a state by state basis. So I guess Canada would be like another example. Some of the provinces there have very specific bounties, if you will, on the recycling piece and the transportation piece. I don't know how well that's going in terms of performance, but concept wise, that's what's being talked about now.
And Leah, I apologize. I have a hard out at 2, just if there's
Okay.
anything else that we can
Wonderful.
run.
I think maybe we'll just end on one question. I know we've had some pessimistic conversations about hazards in the waste stream and everything that comes with that. So I wanted to have the final question be about what is bringing you hope for solving this problem.
Oh, go ahead, Jeff. I'll let you take this one.
Yeah, I think I brought up the pessimist. Well, I love it on the spot. Look, the fact we're talking about it, the fact there are solutions, maybe AI is overused in our industry or everyone's industry right now, but there's solutions to be had in automating processes, making it easier to find hazards and then properly sort them for recycling as well.
Yeah, I would just add that similarly, I think people are starting. I tell people it's like 2 years ago, there was nothing on the table. Now we've at least dumped our jigsaw puzzle out on the table and our pieces are there. And we're saying things like critical materials and we're understanding where stuff comes from and how recycling can contribute. So I think that's progress.
I think companies like Fire Rover are doing really great work with their technology of identifying fires and identifying thermal zones. I know, Leah, we've talked to Raj about, thermal cameras on the scale houses, things like that nature. And I agree with Jeff and Shane. I think the fact that we're talking about it and by dealing with Metro Sites Fire and seeing the outlay, SKB was held accountable and they paid $32 million for their mishap. So I think as more situations like that come up and occur, unfortunately, you have to have loss to make new gain. But I think we're going to see, changes in legislation. We're going to see changes in manufacturing. It's just, will it be in my lifetime? God, I hope so. But, I think we're making headway at least.
Okay, well, thank you all so much for being here, to our panelists, to all of our participants. And I know we're at time, so I'll pass it over to Sophie in case there's any final comments.
Yes, thank you so much. Thank you for joining us today, and thank you to our speakers and our moderator for those wonderful presentations and that conversation. We hope today's webinar has offered valuable perspectives on the future of hazards in the waste stream. A brief survey will pop up after this webinar concludes, and we would appreciate it if everyone could take a few moments and share your feedback. We look forward to seeing you at future NERC webinars and events, and we hope everyone has a wonderful rest of your day. Thank you.